Welcome to All-in-One. Our universe was born about 13.7 billion years ago in a massive expansion that blew space up like a gigantic balloon. That, in a nutshell, is the Big Bang Theory, which virtually all cosmologists and theoretical physicists endorse. The evidence supporting the idea is extensive and convincing. We know, for example, that the universe is still expanding even now, at an ever-accelerating rate. Scientists have also discovered a predicted thermal imprint of the Big Bang, the universe-pervading cosmic microwave background radiation. And we don't see any objects obviously older than 13.7 billion years, suggesting that our universe came into being around that time. All of these things put the Big Bang on an extremely solid foundation, said astrophysicist Alex Filippenko of the University of California, Berkeley. The Big Bang is an enormously successful theory. The beginning traditional Big Bang theory posits that our universe began with a singularity, a point of infinite density and temperature whose nature is difficult for our minds to grasp. However, this may not accurately reflect reality, researchers say, because the singularity idea is based on Einstein's theory of general relativity. The problem is, there's no reason whatsoever to believe general relativity in that regime, said Sean Carroll, a theoretical physicist at Caltech. It's going to be wrong, because it doesn't take into account quantum mechanics. And quantum mechanics is certainly going to be important once you get to that place in the history of the universe. So, the very beginning of the universe remains pretty murky. Scientists think they can pick the story up at about 10 to the minus 36 seconds, 1 trillionth of a trillionth of a trillionth of a second after the Big Bang. At that point, they believe, the universe underwent an extremely brief and dramatic period of inflation, expanding faster than the speed of light. It doubled in size perhaps 100 times or more, all within the span of a few tiny fractions of a second. This rapidly expanding universe was pretty much empty of matter, but it harbored huge amounts of dark energy, the theory goes. Dark energy is the mysterious force that scientists think is driving the universe's current accelerating expansion. In the first moments after the Big Bang, the universe was extremely hot and dense. As the universe cooled, conditions became just right to give rise to the building blocks of matter, the quarks and electrons of which we are all made. A few millionths of a second later, quarks aggregated to produce protons and neutrons. Within minutes, these protons and neutrons combined into nuclei. As the universe continued to expand and cool, things began to happen more slowly. It took 380,000 years for electrons to be trapped in orbits around nuclei, forming the first atoms. These were mainly helium and hydrogen, which are still by far the most abundant elements in the universe. Present observations suggest that the first stars formed from clouds of gas around 150–200 million years after the Big Bang. Heavier atoms such as carbon, oxygen, and iron have since been continuously produced in the hearts of stars and catapulted throughout the universe in spectacular stellar explosions called supernovae. If you have any questions on your mind, just leave it on the comment section. I'll cover it on the next video. Thank you for watching. Hit the like if you like.